Want to generate professional, natural-sounding voiceovers directly from Python without paying a dime or installing heavy software? In this video, you'll learn how to harness Edge-TTS to automate high-quality text-to-speech effortlessly. Welcome! Today we are exploring Edge-TTS, a powerful Python library that interfaces directly with Microsoft Edge's online text-to-speech service. Unlike traditional local synthesis engines that sound robotic, or expensive cloud APIs that require credit cards, Edge-TTS gives you instant access to dozens of hyper-realistic, neural voices completely for free. Whether you are building video generators, automated news readers, or accessibility tools, this library transforms plain text into polished audio files in mere seconds. To understand why Edge-TTS is so effective, we need to look at its architecture. It acts as an asynchronous bridge between your Python script and Microsoft's web-based speech engine. When you send text along with a chosen voice identifier, the library communicates over WebSocket connections, streaming back binary audio chunks that we capture and save locally as an MP3 file. Because it relies on Python's Essentio framework, you can even generate multiple voiceovers concurrently without blocking your main program flow. Before writing our core script, let's verify our environment and ensure we have everything set up correctly. Because Edge-TTS is distributed via PyPI, we can install it using pip. In this first standalone example, we'll write a small utility check that confirms our Python version and prints out how to install the package if it isn't already present on your system. Remember, Edge-TTS requires Python 3.8 or higher to fully support modern asynchronous syntax. One of the greatest features of Edge-TTS is the vast array of regional accents and gender-specific neural voices available out of the box. You can pick from voices tailored for English, Spanish, Japanese, French, and dozens of other languages. Each voice has a unique technical name, such as NUSREN neural or NGBRIN neural. Choosing the right voice allows you to match the exact tone and persona of your project, whether you need a friendly customer service agent or a formal documentary narrator. Instead of guessing voice names, Edge-TTS provides a built-in asynchronous function called list_voices that queries all available options from Microsoft servers. In this snippet, we write a self-contained script using Essentio to fetch and display a filtered subset of English voices. We loop through the returned dictionaries and print out their friendly names and shortcodes so you can easily pick your favorite for your next automation project. At the heart of text generation is the Communicate class within Edge-TTS. This class takes your input text and your selected voice as primary arguments. Once initialized, it exposes an asynchronous save method that handles the heavy lifting of connecting to the speech service, streaming the audio data, and writing it directly to an MP3 file on your disk. Understanding this workflow is key to building robust scripts that process scripts, articles, or prompts programmatically. Let's put the Communicate class into action by creating our first complete audio file. In this script, we define a short welcome message, select the popular NUSREN neural voice, and invoke the save method. Because Edge-TTS operations are fully asynchronous, we wrap our main logic in an async function and execute it using Essentio.run. When this script finishes running, you will have a brand new MP3 file ready for playback. Voice synthesis isn't just about the words you write, delivery matters immensely. Edge-TTS allows you to customize your voiceover by passing extra parameters into your communication setup, or by using SSML markup under the hood. You can subtly alter pitch, speaking rate, and volume to inject excitement or urgency into your narration. These minor adjustments help your automated voiceovers sound much more engaging and tailored to specific emotional contexts. Sometimes you need your voiceover to speak faster for quick tutorials or slower for dramatic emphasis. Edge-TTS supports pitch and rate modifications directly inside the Communicate constructor using simple string offsets like +50% or -10 Hz. Here, we demonstrate how to configure a faster, slightly higher-pitched voice output. This flexibility lets you fine-tune the delivery style without needing external audio editing software. Real-world projects often require generating audio from multi-paragraph scripts or lengthy blog posts. Furthermore, professional video production requires timestamp data so you can generate matching subtitles or closed captions. Edge-TTS not only handles long text inputs seamlessly, but it can also stream word boundary events. These events provide exact start and end times for every single word spoken, empowering you to automate SRT subtitle creation effortlessly. Let's look at how we can consume the audio stream directly while simultaneously capturing metadata like word timings. In this script, instead of calling save directly, we iterate over the stream of messages yielded by the Communicate object. We check for audio data chunks to save our file and look for word boundary events to print out exact start times. This advanced pattern unlocks powerful automation pipelines for video creators and developers alike. You've now seen how easy it is to automate high-quality, professional voiceovers using Python and Edge-TTS. From picking neural voices and adjusting speech parameters to streaming audio chunks and capturing word timestamps, you have all the tools needed to build your own text-to-speech applications. Experiment with different voices and scripts in your next project, and happy coding!